Alright, welcome to this video. It's 2.5 for the Math 980, which is absolute value inequalities. So to start, we're going to consider the inequality of, let's say, the absolute value of x is greater than 5. So what this means, the absolute value of x means whatever number is in here, it has to be greater than, its absolute value has to be greater than 5, which means it has to be further away from 0 than 5. So on a number line, if we're looking at this, here's 0, here's 5. We're not going to include 5 because 5 is not greater than itself, and this is a strict inequality. But anything past that is part of the solutions here. Right? We have all of those. Anything past 5. But it could also be the other way. It just has to be that far away from 0. So that means here at -5, we also get a circle around it, and anything in there is included, right? So if you recall from previous sections, this looks like an OR statement. And in fact, that's exactly what it is. This is the union, or the OR, of x is less than -5, or x is greater than 5, right? The x is less than -5 corresponding to this part, x is greater than 5 corresponding to that part. And this, if you'll notice, this one here looks exactly like this, where the absolute values have just been removed. And this one is essentially the exact same thing except negative on the other side, and we've changed our inequality around, right? But it's an OR, so whenever you have this, the magnitude of, and it is going to become more than just x, it'll become uglier, bigger expressions. But whenever the absolute value of something is greater than a number, it becomes an OR conjunction. So let's take a look at one of these in action. Let's say we have an expression, say the magnitude, or you can call it the magnitude or the absolute value, it's the same thing. Magnitude of whatever 3x minus 2 is, let's say that has to be greater than 2. Right? Okay. And so we saw that this turns into an OR conjunction with the expression inside the absolute value, in this case will either be bigger than 2, or the absolute value of the expression inside here will be less than -2. And that's how we start this off, by saying either this 3x minus 2 is bigger than +2, it's further away than 2, or this expression unchanged, that 3x minus 2, could be less than -2, further away from 0 to the left than 2 spaces. Right? And I'll just go through and solve these. So 3x minus 2 greater than 2, I'll add 2, that gives me 3x is greater than 4, divide each side by 3, and x is greater than 4/3. Or, right, solve the other one. Add 2 on both sides here, plus 2, giving me 3x is less than 0. And if I divide each side by 3, I get x is less than 0. Right? And that's easy to graph out. X is greater than 4/3, just call some spot 4/3, right? It's not even that important where it is. It's there because I said so. Greater than 4/3 is an open circle at 4/3 and shade it to the right. The other part of this, x is less than 0, well x would be, or 0 would be here, and less than 0 is over there. So if we wanted to write this in interval notation, we would write this as -∞ to 0, closed, with a union, and then 4/3 to infinity. And that's our solution. let's examine another type of question. Let me just change this pen out real quick. There we go. All right. So we just saw that the absolute value of something being greater than a number turns into an or conjunction. Let's go back to something simple. Let's say the magnitude of x, or the absolute value of x, let's say is less than 5 now. Now this means that this value of x cannot go beyond 5, right? It has to be closer to 0 than 5. So again, here's our 0, here's 5, it's an open, and it's all of those numbers that aren't further away from 0 than 5 is, right? But again, that's two ways. We can go the other way, we just can't go 5 units or more away in the other direction, so up to -5, open, all of those values on the inside. And you can recognize this graph as an AND conjunction of two inequalities. And that'll happen every time that this is solvable, right? You'll end up with an AND. The magnitude of something has to be within these, it's stuck, it's in the AND. That expression is that x has to be less than 5 and x has to be greater than -5, right? X has to be less than 5, pins it in from the right. X has to be greater than -5, pins it in from the left. And then if this were more involved expression up here, we would then solve, right? But we're good here. Let's see one of these in action. Let's say I have the absolute value of 2x plus 3 is less than, 13. Okay? Once again, I'm going to jump straight from here into my AND conjunction. If the absolute value of something is less than, I need to recognize that that is an AND. I need to be able to tell that the magnitude of something being greater than is an OR, the magnitude of something being less than is an AND. I have an and so I'm going to create my AND conjunction. 2x plus 3 is less than 13, and the other side of this is that expression doesn't change, 2x plus 3. What does change is the inequality, and the number on the right goes negative. And I have my AND conjunction, and I just have to solve both of these independently. So I will. -3 gives me 2x is less than 10. And if I divide 2, I get x is less than 5. Right. Same thing over here, -3 from both sides. That gives me 2x is greater than -16. Divide each side by 2, and I have x is greater than -8. And again, this is an AND. I don't know why I went capital big, but forgive me. For all those OCDs out there, that's better. But this means less than 5, so 5 is here, open, and it's going to be to the left, but how far? Well, x has to be greater than -8, and so that's the other side of this. And it's those, it's the numbers between -8 and 5, and we saw before that when we have an AND, we don't have to conjoin them with a union or an intersection anymore, because it's just one interval. It's simply the numbers between -8 and 5, and there's our interval notation solution. All right, let's take a look at some bigger stuff. The one thing that you want to do here is isolate that absolute value. Because as it gets bigger and uglier, some of these questions will have more and more junk attached onto it. So let's do a couple. Let's start pretty easy. I'll start with something like, say, 2x plus 1 minus 4 is greater than, let's say, 20. Right? I want to isolate this absolute value. I want to treat it like it's its own little thing, which means I want to get this 4 out of my way. So add 4, add 4. That's gone, and the absolute value is now isolated. This is what I want before I start trying to break it up into two inequalities. This is the goal for step 1, is to isolate that absolute value, and then you can break it up and say, this, 2x plus 1, is greater than 24, right? And again, since its magnitude is greater than, that's an or statement, right? Or that 2x plus 1 is less than negative 24, okay? And then we solve each of these. Minus 1, that gives me 2x is greater than 23. And if I divide each side by 2, then I get x is greater than 23 over 2, right? Or minus 1, and I get 2x is less than negative 25. Divide each side by 2, I get x is less than negative 25 over 2. And there's my solution. And of course I could graph these, I could put them into interval notation, know how to do those, but I'm not going to for this one. We're just going to move on. Okay. So we had that little 4 hanging out there, we had to move it out of our way. Or was it a 1? Now I can't remember. Doesn't matter. What I want to do here is, sometimes you'll get stuff that looks like this. And really this is very similar to the last problem we had, except now that number is kind of hanging out at front. But I want to start there and get rid of it, right? And I've got this magnitude, I've got a less than sign, so it's easy to start thinking, oh, this is going to be an or statement, but you don't want to make those judgments until you've got your absolute value isolated. So let's isolate it. The first and foremost, I don't want to see you take this 3 minus 2, because this 2 is multiplied by this junk, and you cannot then add it or subtract it from the 3. What you can do is subtract that 3 and get it out of your way. 3's gone, you're left with this negative 2 times the absolute value of x plus 1, less than negative 22, because counting is hard. And then the next thing I don't want to see is to take this negative 2 and just distribute it through. You don't want to distribute anything into your absolute values, especially a negative, because then you lose information, right? What I do want to do, though, is divide out that negative 2, and I'll divide both sides. I'm left with, then, the absolute value of x plus 1. I have to flip this side because it's an inequality, and I've divided by a negative, so that goes greater than, and that goes positive 11. Right? Now I'm ready to cut this into two inequalities. X plus 1 is greater than 11, or x plus 1 is less than negative 11. Okay. And I'll solve each of these. I'll subtract 1. That gives me x is greater than 10, or x is less than negative 12. Right? And I'm done. That's my solution. Once again, you can put this into graphical form or interval form, right? But there we have it. There's a solution. Okay, let's take a look at let's say, here's a good one. From the example about halfway down in this reading here, let's do this one. Minus 6 minus 2 times the absolute value, 2x plus 5. is greater than -8. So again, I've got this 6 hanging out here. I need to get rid of it first. I've got this -2 hanging out here. I need to get rid of it as well. So let's start by adding 6 to both sides. That leaves me with -2 times the absolute value of 2x plus 5 is greater than -2. Okay. I want to divide out this -2, so I'll divide by -2. The 2 and the negative cancel on the left, leaving me with the absolute value of 2x plus 5. I have to switch this because I just divided by a -2, and -2 divided by -2 is a +1. I can now turn this into two inequalities. That is to say, 2x plus 5 is less than 1, and it's a less than, so it's an and. So I'm stuck inside, so that's an and. That 2x plus 5 is greater than -1. And then I solve. -5 from all of these sides gives me 2x less than -4. Divide by 2 gives me x is less than -2. On the other side, same deal, -5 from both sides. That gives me 2x is greater than -6. And if I divide by 2, I have x is greater than -3. So kind of a small range on this one. If we graph that, x is greater than -3 is here. It's an open circle. X is less than -2 is here, so it's just those numbers between -3 and -2. So the key here up to this point is to isolate that absolute value expression and then break it into 2. But we'll see that that's not always possible. We'll look at this next example. We have 8. In fact, let's do this. Let's do 10 plus 3 times the absolute value of x plus 5 is less than 5. Looks like we can do it, right? It looks great. Let's do it. Let's jump into it. The first thing we want to do is isolate that absolute value. So I will subtract 10, and that leaves me with just a 3 times the absolute value of x plus 5 is less than -5. Right. Great, looking good so far. Let's get this 3 out of our way, divide each side by 3. So I've got this absolute value of x plus 5 is less than -5/3. Right? Should I make it look like an octagon? Probably. Stop here. We're done, in fact. There's nothing else we can do because this is saying that the distance something is from 0 is going to be less than a negative number. And those distances are always positive, or 0 itself, by definition. We're never going to get a negative number out of a magnitude, out of a absolute value. And therefore, if I have to compare this by saying, oh, it's going to be less than this negative number, no, it's never going to be. There are no solutions here. So we would say either no solutions, or you can draw the little O with a circle through it. That means the empty set. There's nothing here. There's no solutions. You could go through and, I gotta make that, I'm the OCD one here, but I'm gonna make that look like a stop sign. But you could go through and say, well, I'm gonna turn this into 2 inequalities and get 2 answers that are worthless, because none of them are gonna work out, because your magnitude will never be less than a negative number. So we're done, and that's it, right? So be careful of these guys. let's look at, let's say, 2 minus 5 times the magnitude of 2x plus 1 is, I want this, less than, you need less than or equal to if you want here, but let's say 47. Okay. Again, I want to try to isolate this absolute value. So I'm going to start by subtracting 2. Gone. That leaves me with this negative 5 times the magnitude of 2x plus 1 less than or equal to 45. Okay? And if I divide by negative 5, that's the magnitude of 2x plus 1. I have to switch this. It's now greater than or equal to. That gives me negative 9. And I can stop again, but for a different reason. That stop sign is a little sad looking, but I can stop here because this is telling me that the magnitude of this number, which is always 0 or more, is greater than or equal to negative 9. Well, which numbers are those? All of them. No matter what I get out of 2x plus 1, that number has a magnitude definitely greater than negative 9. Even if it's 0. That's the worst case scenario, is I could get a 0 in here. It's definitely still greater than or equal to negative 9. And so anything will work. It doesn't matter. I don't have to solve this any further. This is all real numbers will work. Which again is that double barred R, all real numbers. Or if you want in interval notation, you can write it from negative infinity to infinity. It's everything in the real number line, right? So watch out for these when you get an absolute value isolated and a negative on the other side. If that absolute value is greater than that negative, it's everything. If that absolute value is less than that negative, it's nothing. So be aware of those. All right, thank you, and I will see you guys for the next section.